Hello and welcome to another Miss B's Resources tutorial. Today we're going to look at adding and subtracting fractions without a common denominator. You should have previously watched adding and subtracting fractions with a common denominator to take part in today's tutorial. We're going to first look at some simple examples where we only need to change one fraction. If we look at this first question here, we have 1/2 add on 1/4. So I'm going to take this to diagram form again so we can see what's happening. You'll notice that I've split my cake with a bold line into halves. I've also put a dotted line across, which we'll talk about later. So I've got 1/2 of my cake, so I'm colouring 1/2 of the cake. And then I'm adding on 1/4. Now the dotted line I've put on because the second fraction is in quarters, so I've put the dotted line on so I can see how many quarters this half is equivalent to. So this tells me that 1/2 is equivalent to 2 quarters. So in total, when we're doing 1/2 add 2 quarters, I've got 1, 2, 3. So in total, I've got 1, 2, 3 quarters. So in my final diagram, I'm going to colour in 1, 2, 3. So my answer of 1/2 add a quarter is 3 quarters. Now, we're moving on to the next one. You've got 3 quarters, take away 3/8. So again, I'm going to put this into diagram form. I've got 3 quarters. And I've got 3/8. Again, you'll notice that the dotted lines are in the pictures. This is so we can see how that diagram would separate into eighths. So in this first diagram here, I actually have 3 quarters, which is the same as 6/8. And the second diagram, I've got 3/8. So 6/8 take away 3/8 leaves me with 3/8. 3 out of 8. Can you see how we could rewrite this sum so the denominator is the same? Now we can't add or subtract fractions when the denominator is not the same. Finally, we're going to look at the last question without using diagrams. We've got 2/3 add on 5/6. Now, 3 and 6 are both in the 6 times table. So what I'm going to try and do is get this first fraction to have a denominator of 6. Now 3 goes into 6 twice, so I'm going to double this fraction. I'm going to times it by 2. So 2 times 2 is 4, and 3 times 2 is 6. Now I'll put a box around it so I remind myself I'm going to times the top and the bottom by that 2. And we're going to add on 5/6. That is the same as 9/6. Now we've got a top heavy fraction here and also a fraction that can be simplified down. Both 9 and 6 can be divided by 3. They're both in the 3 times table. So 9 divided by 3 gets you 3, and 6 divided by 3 gets you 2. So 3/2. 3/2 can then be converted to a mixed number. 3 divided by 2 is 1, remainder 1. So you've got 1 whole and a half left. And that is your final answer. Well done if you got that. On the board now, there's some simple questions for you to have a go at yourself. So freeze the screen and have a go at doing these. The answers. You should have been able to see that both 5 and 10 are in the 10 times table. And 5 goes into 10 twice, so I need to multiply this first fraction by 2. So 2 times 2 is 4, and 5 times 2 is 10. Second fraction stays the same. 3/10 add on 4/10 gets you 7/10. Okay, the next question, 5/9 take away 1/3. Well, If you look at the denominators, 9 and 3, 9 and 3 are both in the 9 times table. So I'm going to try and get this second fraction to be 9. The denominator to be 9. Now, 3 goes into 9 3 times, so I need to times this fraction by 3. So 1 times 3 is 3, and 3 times 3 is 9. 5 ninths take away 3 ninths is 2 ninths. We're on a roll. Last but not least, 3 quarters, add on 1/12. 4 and 12 are both in the 12 times table, so I'm going to try and get the denominators to be common by getting it to 12. 4 goes into 12, 4, 8, 12, 3 times. 3 times 3 is 9, 4 times 3 is 12. Add on 1/12, that gets you 10/12. Now this can be simplified. Both 10 and 12 are in the 2 times table, are both even numbers. So I'm going to halve both numbers to get the simplified answer in its simplest form of being 5/6. Well done if you got them right. Now we're going to have a look at some harder examples where it isn't as obvious what we need to get the denominators to. And we're going to look at using a method called the X factor method. Now, we've got 3/5 add on a quarter. So, if I put up the top here, 3/5 and 1/4, the first thing that we're going to do is we're going to box these off. So we're going to just draw boxes around them. The next thing we're going to do is we're going to identify what we're multiplying by. So you multiply by the opposite denominator. So this first fraction here we're going to multiply by 4. And the second fraction we are going to multiply by 5. Okay, you cross multiply, you're multiplying by the opposite bottom number. And the way this works is you're going to multiply this fraction by 5, and you're going to multiply the whole of the first fraction by the 4, the bottom number. And can you see how that kind of makes your X where the arrows cross over? That's your X factor version of it. What we need to do now is we need to times by these numbers. So how would you fill this in on your information, on the question? Looking at the first question now, what we're going to do is we're going to box both fractions. We're going to times the first fraction by 4, the opposite denominator, and we're going to times the second fraction by 5. So we're going to do 3 times 4, then we're going to do 5 times 4. So 3 times 4 is 12. 5 times 4 is 20. Add on, no matter what the symbol is there, you just put it and you copy it across. Add on, 1 times 5 is 5, and 4 times 5 is 20. Now, 12 20ths add 5 20ths is equal to 7 20ths. Okay, we're going to look at the next question now. Again, the first thing we're going to do is we're going to box them. Then we're going to identify what we're going to multiply by. So, you multiply by the opposite bottom number, the opposite denominator. So you're going to multiply the first fraction by 8, and we're going to multiply the second fraction by 3. So our new answer, our new fractions are going to be 2 times 8, which is 16, and 3 times 8, which is 24. Take away, subtract 3 times 3, which is 9, 8 times 3, which is 24. That will leave us with 16, take away 9, is 7 24ths. Well done if you've got that. On the next slide now, we are going to put up a screen for you to have a go at doing some questions yourself. Freeze the screen and have a go. Okay, you should have managed to have a go at these and freeze the screen. If you haven't, freeze the screen and have a go. The answers. The first thing that you need to do is box your fractions. Then you identify what you're going to multiply. So you're going to multiply the first one by 7. And you're going to multiply the second one by the 5. You multiply by the opposite bottom number. So 2 times 7 is 14. 5 times 7 is 35. Add on 3 times 5, which is 15. 7 times 5, which is 35. That leaves you with 29 out of 35. Okay, the next one, you're going to do exactly the same again in the same order. You're going to box the fractions. But this time we're taking away, but it doesn't change what the steps that we do. We're going to box the fractions, identify what we're multiplying by. So we multiply the first one by 4 and the second one by 9. 5 times 4 is 20. 9 times 4 is 36. Take away 1 times 9, which is 9, and 9 times 4, which is 36. So that is going to leave us with 11 over 36. Last but not least, we're going to look at 3/4 add on 5/6. So we're going to box them. Then we're going to identify what we're multiplying by, the opposite denominator, the opposite bottom number. We're going to multiply the first one by 6 and the second one by 4. 3 times 6 is 18. 4 times 6 is 24. Add on, click and add. 5 times 4 is 20. And 6 times 4 is 24. That leaves us with 38 over 24. Right, well, we're going to end up with a mixed number here, so let's see what we get. 24 goes into 38 once, goes into 24 once, remainder 14. Now, 14 and 24 are both even numbers, so we can cancel that fraction down to leave us with 1 and 7/24. Divided the fraction by 2. Well done if you got them right. Last but not least, we're going to look at an examination question. So Jessica wants to attach a ribbon around her wardrobe. She has 4 meters of the ribbon. How much more does she need? Right, well, she wants the ribbon to go all the way around her wardrobe. So we need to know what the size of the other edges are. The opposite sides are the same. So you know that this edge here is 1 3/4 of a meter, and you know that this edge here is 2/3 of a meter. And you're going to find the proof, so you need to add these parts together. So the sum that you're going to be doing is you're going to be doing 2/3, add on 1 3/4, add on 2/3, add on 1 3/4. Well, that's the same as doing 2 6/4, add on 4/3, which is the same as 3 2/4, add on 1 1/3. Okay, now we're going to look at this because we've got 2/4 and we've got 1/3. Well, 2/4 can be simplified down to get us a half. So 3 1/2, add on 1 1/3. we need to get these fractions the same. So the bit that I'm struggling with at the moment is a half add a third. Because we know that 1 add 3 makes 4. If you look at just the whole numbers, the 3 add on the 1 makes the 4. Okay, so we're going to look up here at the half add a third. I'm going to follow these steps through as normal. We're going to box. We're going to identify. And now we're going to get our new fractions. 1 times 3 is 3. 2 times 3 is 6. 1 times 2 is 2. 3 times 2 is 6. 3 add 2 makes 5 sixths. So you've got 4 and 5 sixths. Now that's not our final answer. She has 4 meters of ribbon. So we want to know how much more does she need? Well, she needs 5 sixths more worth of ribbon. So the final answer is 4 and 5 sixths. Take away 4 leaves you with 5 6 meters worth of ribbon. Now the marks, you're wondering where they're coming from, and I apologise about the mess on the screen. Okay, I hope you had more room to do your working out. The marks come from showing that you need to add the sides together. It comes from converting, showing that you've got them and collect them together, converting. So these 2 marks here, this one here and this one here are the same mark. And then it comes to show, there's a mark there and there's a mark for your answer. So well done if you got that.